Remember that in a competitive equilibrium, we need supply and demand to be equal to one another for each of the two goods. So the markets for both goods, apples and bananas, have to clear. Just a reminder, when we say that the market clears, we mean that the supply and demand are equal to one another. So if we're trying to find a competitive equilibrium, what we're going to do is we're going to say, we have some prices, and we're going to let both the consumers maximize their preferences at those prices. So we're going to have both Rob and Friday optimize at those prices. And let's suppose when Rob optimizes his preferences, he picks the bundle AR star, BR star. And when Friday maximizes his preferences, he chooses the bundle AF star, BF star. Again, we're not necessarily at an equilibrium here, but we just have these prices, PB, PA, and PF. Now, if both of them are maximizing their preferences, if they're both optimizing, then they're going to choose these optimal bundles such that the cost of the optimal bundle is exactly equal to the consumer's income. So Rob's income, remember, he's endowed with 20 apples and 30 bananas, so his income is 20 PA plus 30 times PB. So this bundle, this optimal bundle AR star BR star is such that if we multiply AR star by PA and we multiply BR star by PB, that's going to be equal to his income. Similarly for Friday. So what we can do now is we can just add up these two equations, right? Add these two equations together. So let's add up the first term of each and factor out the PA to get this, right? So PA times A star R plus A star F. Add the second two terms together to get this when we factor out the PB. Again, it's PB times BR star plus BF star. We've got 80 times PA and 50 times PB. That's what we got here. So what we can do then is actually to subtract 80 PA from both sides and 50 PB from both sides and factor out the PA and the PB. So we've got these two terms on the bottom. So we can simplify this equation to this. Now, let's take a closer look at this last equation. Let's look at each of these terms. In particular, let's look at the second part of each of these terms. So, what is 80? 80 is the supply of apples. What is AR star plus AF star? AR star is the amount of apples demanded by Rob. AF star is the amount of apples demanded by Friday. So altogether, this is the market demand. Market demand for apples. So this part here is excess demand for apples. Similarly, this part here is excess demand for bananas. So what this is saying is if this equation here in this red box says, if we multiply the excess demand for apples by the price of apples and add to that the excess demand for bananas times the price of bananas, that has to equal 0. So that's what we've got up here. Now, we're looking for an equilibrium, and let's suppose we've found prices that cause the market for apples to clear. In other words, they cause the market for apples to have 0 excess demand. So the market demand for apples and the supply of apples are equal to one another, which is why there's 0 excess demand. Well, if that's the case, that means this first term is equal to 0. Then the second term has to equal 0 as well, because when we add them together, we get 0. since we have this equals 0, remember bananas can't be free. So PB isn't 0. So if PB times excess demand for bananas is 0, and PB isn't 0, it has to be that excess demand for bananas is equal to 0. Which means that the market for bananas clears automatically. We started with a pair of prices, PA and PB, such that the excess demand for apples was 0, so the market for apples cleared. From that, we were able to conclude that the excess demand for bananas was 0. We could have done it in the reverse. Perhaps we could have found prices that caused the excess demand for bananas to be 0. Well, that would allow us to conclude that the excess demand for apples would also have to be 0. This is called Walras Law. It says that when you have two goods, it says that if one of the markets clears, then the other market has to clear as well. So you only need to check that one of the two markets clears. In general, if you had an arbitrary number of goods, not just two, it says that if all but one of them clears, then the last one clears as well. So you only need to check if you have n goods, you only have to check that n minus 1 clear. Then the nth market also has to clear.